sublevels are just your layers, okay? So we just saw that little video of scandium. So what we're going to do is let's go ahead and label our different parts of the periodic table. This should be a very easy review here, okay? And I'm going to be using my different colors just so that when I'm doing my configuration, I'll have the different colors there. So what is this first area? What are the first two groups called? What sublevel is it? S sublevel. Good. You guys can't see that, can you? So we have S sublevel. How many orbitals are in the S sublevel? 1. So 1 orbital. How many electrons does that 1 orbital hold? 2. Okay. And you guys just saw in the little video. What does that, by the way, this is showing you an x-axis, a y-axis, and a z-axis. The z-axis kind of comes out towards you. Okay, so it's 3-dimensional. What did the s orbital look like, or s sublevel stuff look like? What did it look like? Like a big sphere, exactly. So we're just going to have that. And there you go. Okay? All right, so there's S. Let's jump across over here. Okay? What is this area off to the right? This one over here. What's this one? This is the P orbital. Okay? So we're going to say P orbitals, or P sublevel. There you go. How many orbitals are within this sublevel? How many orbitals? How many? 3. Good. Okay. How many electrons does that hold? 6. Okay. What did that shape look like? So kind of like that, and then we had kind of like that. I'm only going to draw one of them, okay? But you guys saw 3 of them make up a full subshell, okay? But that's one of them. There's one that goes this way, and that way, okay? All right, what is the middle area called right here? D, okay? So this is D. How many orbitals does the D sublevel have? 5. Okay. How many electrons do those 5 orbitals hold maximum? 10. Okay. And then finally, down below, we have what sublevel? F sublevel. Okay. And F sublevel has how many orbitals? And how many electrons? 14 max. Okay? All right, so that should have been a review. Oh, forgot the drawings for these two guys. Okay? So remember, F is the crazy one. Okay, you guys didn't even get to see it up there. So what I like to do is I'm going to do a donut with a flower and leaves on my flower, and we're going to leave that one alone. All right? But the D orbital, what did the D orbital look like? You guys remember? It was a few of those dumbbells, right? Basically. So we're gonna do the basic one, which is two of those dumbbells. Okay? And there's an extra little area in there. Okay? And remember, 5 of those stack up for that whole subshell or sublevel. Okay? All right, so now what we're going to do is we are going to go ahead and start doing our electron configuration. When we get down to the 4th level, we're going to see that things get a little crazy, and we're going to talk about it, okay? But what I'm going to do every once in a while is kind of draw you where we're at in terms of what the orbitals are looking like stacking up. But remember what you guys just saw in the video, okay? All right, so let's go ahead and start with over here. What are we starting with? What goes in this first box? Not those, for electron configuration. We're writing the electron configuration of the periodic table. 1s1, right? Okay, so we're at 1s1. Okay. Then we look over here. 1s2. Okay. All right. Now what are we doing? We're on this next level. So we've now done, just so you're aware, what we've done is we've now covered this guy. Here's 1s2. Okay, got it? All right, so next part is going to be what? 2s1, and then 2s2. You see that? So, what did I do? I just added a bigger shell. Okay. Now where do I go from here? Across or down? Across. Follow it left to right, right? Okay, so we're going to go 2p1, 2p2, 2p3. Okay. 2p4, 2p5, and 2p6. Okay? How are we doing? Doing okay? Okay, so at this point, okay, now what I have is I'm still on that second level, so I'm going to keep blue, but now I have the ones that are kind of going like this, right? I have my dumbbells, okay, and I'm on each of the axes, but I am still on that second sublevel. So the question I'm going to ask you right now, we're going to check this every once in a while. How many valence electrons does this thing have? What is a valence? Actually, let's start with what is a valence electron? It's the electrons that are what? On the outermost energy level. They're on the outside. How many electrons do I have currently that are on the outermost energy level? I heard one person say it. It's not 6, it's what? 8. We have 8 right now, okay? Because we have the 2, we have the 2 that were part of this sublevel, and then we have the 6 that were part of your dumbbells. Okay? All right, so you have 8 right now. All right, so it comes from your S and your P orbital. Okay, so let's see how that goes on the next level. All right, so now we're at 3rd energy level, so we're going to put in what? 3s1, 3s2. Okay, I jump across, just follow it left to right. Actually, no, stop there for a second. I want you to look at my picture again. Okay, so what did I just do? I just put a big green bubble around all that. So now, how many valence electrons do I have? Which energy level am I at? What layer am I at right now? I'm at 3. How many electrons do I have? 2. You guys said 3s2, right? How many valence electrons are there? 2. The answer is 2. Okay? All right, so we'll keep approaching that question. So if you're still not getting it, we'll get back to it in a second. All right. So we're going to jump across. Okay? We're going to have 3p1, 3p2, 3p3, 3p4. Pause. How many valence electrons do I have now? 6. Good. So you added who? Your S level and your P, right? Okay, good. So you have 6 total because you're on the 3rd energy layer. The 3rd energy layer, and you have 1, 2, 3, 4, 5, 6. Do you see that? We're all good? Okay, awesome. All right, so let's finish up this row. We got 3p5 and 3p6. So how many valence electrons do I have now? 8. Good. Okay. Now we have 8. All right. So told you guys things get funny around 4. So let's focus in on 4 now. Okay. So excuse me. All right. So 4. We're going to start with the basics. 4s1, 4s2. right? So what kind of shape just went around the whole thing? A big circle, right? A big sphere again, okay? Now we start entering, because we have to read it from left to right. Now we're entering this D sublevel, right? So for the D sublevel, what we've got to remember is that we have a rule, n minus 1, okay? N means your energy level. So what number am I starting with here? 3. Okay, so it's going to be 3D1. But hold off. Don't just start writing them all. Okay? I'm going to have you guys write something at the top of your periodic table right here. Okay? Write valence electrons, so you're ready to go. And then take a second, and I want you to look at where we are on our periodic table. 4s1, 4s2, 3d1. How many valence electrons do I have? 2. Why? Say it a little bit louder. But why? How could you, like, not knowing that, how could you look at this and tell me it is only 2? Yes. There we go. Do you guys see that the 4th level is the highest energy level that we're at, right? That's the furthest away from the nucleus we are. So there's only 2 electrons. 3D just jumped back a layer. Do you guys see that? So because of that, okay, because of what Jenny was saying over there, she said valence electrons only use S and P. Okay? And that's going to be why we're going to be jumping back a level. There's more to it, but it's a little beyond the scope of this class. Okay? This is going to help that rule stay in place no matter what. Because we will always jump back in energy level, no matter where we go in the D or in the F. Okay? All right. So are we all clear? Valence electrons only use S and P. Can we try to remember that? Okay? I'll be asking you guys again along the way. All right. So let's keep filling out this D sublevel. So we got 3D1, 3D2, 3D3, hold off. Okay. 3D4 gets funny. Who is 3D4? Put a star next to that one, by the way. Who's 3D4 on your periodic table? Huh? CR. It's chromium. Okay? Okay. You don't have to draw this. Just look for a second. When you look at your orbital notation for this, okay? 4, 5. All right, so this is your 4s, this is 3d, okay? All right, so right now where we're at is we have 4s full, and then we have 1, 2, 3, right? So chromium technically would be this, correct? Okay, so this is a higher energy level, this is a lower. We need to take care of our lower stuff first. So what's going to happen is it's going to take 1 from that and fill up all the bunk beds. Oh, that's not a 1. It's going to fill up all the bunk beds, all right? It's a little more complicated than what I'm saying, okay? But try to think of it like symmetry or like stability or balance, okay? Because if we do it this way, now what? Everybody has their own bunk bed. Do you see that? Or they have their own orbitals. And it's just a little bit better. Everything gets back to being lower energy, okay? Everything wants to use the least amount of energy possible, okay? So what I need you guys to do is you do have to know these. You have to know the 2 exceptions, and that's going to be chromium, and it's going to be at the end, copper. Look where copper is on your periodic table real quick for me. Copper would typically be what? 3D what? 9, right? So 3D9 would look like this. 1, 2, 3, 4. Do you see that that's just awkward? This is a lower energy level. Why waste it on an upper one? He's going to take 1 to fill it up. Okay? So we're going to write this right now. So if that just went over your head, you just got to memorize it then. So that's the best I can explain it. All right, so here we've got, what you're going to write is 4s1 3d5. So 3d4 does not exist, basically. Okay, that says 4s1 3d5. So then the next one, we're going to go back to 4s2 3d5. Okay? So question. Chromium. How many valence electrons does chromium have right here? According to this. Huh? It only has one. Yeah, it only has one in its outer level. And then what does manganese have? 2. Okay? So just kind of be aware of that. But like I said, the stars are the ones that are the exceptions. Let's just keep going. So now we're back at 4s2 everything. So 3d5, we're going to go 3d6. This one's from your lab. That's iron. 3d7, 3d8. Get complicated again. And we're going to go 4s1, 3d10. And then 4s2, 3d10. Okay? So what I'm going to do, I am going to highlight these 2 columns, just so I make sure that I pay attention to them. Okay? All right. How are we doing, you guys? A-okay? Kind of, sort of? You'll get it. You'll get it, I promise. All right. So now let's keep going. So now we're at, oh, why? Why, iPad? Why did you do that? There we go. Okay. So now we're over here. So we're back on the 4th energy level or 3? 4th. So we're going to go 4p1, 4p2, 4p3. How many valence electrons at 4p3? 5. Good. Nice work. 4p4, 4p5, 4p6. Okay. Whew. All right. So 4th energy level is special. All right. And then we're going to see 6 is also going to be special. All right. So you guys do the 5th row, or at least start shouting it out to me. And let's 8, 9, 10. Ooh, I almost couldn't count. How are you guys doing? Awesome. All right, so we got all the way to the end of that one. Okay? We're at 14. Okay, so now we go back up. Where are we starting in the D sublevel? 5. Good. Nice work. 5D1, 5D2, 5D3. Okay? 6S1, 5D5. How many valence electrons right there? How many? Only 1. Good. And then we're going to go 6s2, 5d5. And then 5d6, 5d7. And then 6s1, 5d10, 6s2. 10. Okay, and then let's finish it off. We're almost there, you guys. So close. Then we're going to finish with 6p1, 6p2. How many valence electrons right there? 6p2. 4. 6p3, 6p4, 6p5, 6p6. And I am done. Whew. Good job, you guys. Nice work. So what I need, the big takeaways here. Valence electrons only use what two sublevels? S and P. You go to the outermost energy level and count up their S and P electrons. That's it. Okay? So when we are doing these things like we did in the lab where you have ions, where you're taking away electrons or you're adding them too, you take them away from the valence ones first. Okay? The outermost energy level, the valence electrons. The other big takeaway from today is that they stack up like this. And so in order to follow that rule, when we get to a d orbital, it has to go back in energy level so that the only ones that are on the outside are S and P. Okay? So I'd say those are the big takeaways. Do you guys have any questions for me? Okay. All right.
You have to memorize the Star Wars?
Yes, you do need to know this trend, the highlighted one with the stars. Okay, and remember where it comes, you know, the easy way to kind of think of it is that stability. If you look at your orbital notation, give everybody their own bunk bed if you can. Fill up all the bunk beds on the lower level than the higher level. Okay, just look at it kind of like that. So that part.